Welcome to Ask and Learn.
In this problem, we have to first find out the value of equivalent impedance across these 2 points, right? So we have to find out the Z equivalent across this. The nomenclature may be different, but just we have to find out the equivalent impedance across these 2 points, right? So what I am going to do is, first of all, I will find out the Z equivalent of these four elements, right? And then, as you can see, if I found the equivalent impedance across these four and just simply add 2 ohms, we will get the Z equivalent of this problem, right? So let's suppose the equivalent impedance across, so let's suppose the equivalent impedance across this is our Z equivalent prime, right? So what I'm going to do is, first of all, find the value of Z equivalent prime. So we are going to first find out the Z equivalent prime. So as you can see, these two impedances are in series, and these two also are in series. So what I can do is I can redraw the circuit like this. This is our 2 ohm, and then let's suppose this is the equivalent impedance of these two series elements, and similarly this is the impedance of these two series elements, right? So what I'm going to do is, first of all, finding these two equivalent impedance of these two series elements, right? So as you know, the equivalent impedance of series elements can just find out by just adding both of them. So as you can see, this is minus 6j, which is capacitance, and this is our 4 ohm. So the value of this, let's suppose this is the equivalent impedance of these two elements. So this will become 4 minus 6j, right? Similarly, as you can see, these two elements are also in series. So the equivalent impedance of these two elements will be 3 plus 4j, right? Now the value of this element is 2 ohm. What we can do is, as you can see, these two are in parallel. So let's suppose the equivalent impedance across these parallel elements is Z1. So what I can do is, I'm just writing the formula for parallel impedances, right? So the value of parallel impedances, let's suppose this is 1 upon Z1 is equal to, I'm just writing formula first, right? So this is for the, I'm just writing over here, this is formula, right? So the formula is 1 upon Z equivalent is 1 upon Z1 plus 1 upon Z2, right? This is the general formula which you can memorize it, right? So now I am calculating the value of Z1. So as you can see, this is our first, let's suppose this is our, oh, this is our one element, and this is our another element, right? So what I'm going to do is, I'm finding the value of Z1. So just put the values in the formula. The 1 upon Z1 will become 1 upon the first element. The first element is, let's suppose this is our first element. So this will become 1 upon 4 minus 6, right? And plus the another element is, suppose this is our Z2, right? So this will become 1 upon 3 plus 4j. So this will become 1 upon 3 plus 4j. Now let's calculate the value of Z1 just by simplifying both of these terms. So what I'm going to do is, I'm just finding the value of Z1. So this will become something like this: 1 upon Z1 plus, if I get the conjugate over numerator, what I will get is, I will get 4 plus 6j upon 16 plus 36 plus, this will give us 3 minus 4j upon 9 plus 16, right? So if you further simplify, what you will get is 1 upon Z1. Just calculate all these terms, you will get the value 256 minus 58j upon 1300, right? So if I as I am interested for Z1, not for 1 upon Z1, so just reciprocate both of the terms, you will get Z1 as 1300 upon 256 minus 58J, right? So the value is, if you further simplify by just getting the conjugate of these terms in the numerator, what you will get is the final value of Z1 is 4.83 plus 1.09 J, right? So this is our Z1. Just simplify this term, you will get it, right? So this is our Z1 in ohms, right? Now what I am going to do is, as you can see, the one resistor is left out, right? So I'm just writing over here. So the equivalent circuit will be like something look like this. So this is our resistor, and then this is our Z1, right? So this value is Z1, and this is our 2 ohm. So as you find out the value of Z1, so what you will get is, this is our 4.83 plus 1.09 J, right? So what I'm going to do is, I'm just finding the equivalent of these two, right? So the equivalent of these two will be, just add them. So you will get 2 plus 4.83 plus 1.09 J, right? So the equivalent impedance of the circuit, that is Z equivalent, will be, add both of them, you will get 6 plus 83 plus 1.09 J, right? So this is our first answer for this question. And the next one, what we have to find out is, we have to find out, so we have to find out the current, right? So the current which is flowing in the circuit. So let's suppose this is our I, right? So we have to find out the value of this I. Okay. So as you can get the, now I am going to solve the second part. So this is our part second, and we have the value of voltage vector, that is the voltage vector is 120 angle 10, right? So the voltage vector is 120 angle 10 degrees, and as I find out, the value of Z equivalent is 6.83 plus 1.09 J, right? So these two values which we have already know from the question. Now what we have to find out is, we have to find out the current, right? So the formula for the current is, the current vector is equal to the voltage vector by impedance vector, right? So as you can see, this is in a rectangular form. So just with the help of calculator, convert it into the polar form for the simplicity for the calculation, right? So with the help of calculator, you will get the value of impedance in the polar form, which is 6.917 angle 9.1 degrees, right? So this is the polar form. With the help of calculator, we can easily calculate it, right? So we get the value of Z equivalent in the form of polar form, right? Now just put the value in the formula, you will get the value of current vector, right? So the current vector will be something like this. So the current vector I will be the voltage vector, that is 120 angle 10. So this is 120 angle 10 by impedance, that is 6.917 angle 9.1. So the final answer of I will be like, you have to, what you have to do now, you have to just divide 120 by 6.917 and subtract 9.1 from 10, right? So you will get the value of I, which is 7 point, sorry, the value of I will be 17 point, just calculate with the help of calculator, you will get the value of I, that is 17.35 angle 0.9 degrees, right? So this is our final answer for I, right? So this is the current which is in ampere. Similarly, the value of Z equivalent is given over here in ohms, right? So that's it for this problem.